Hello students, I am Shubhashish. Previously, you've learned about what is rational numbers. All natural numbers, whole numbers, integers and fractions are rational numbers. Every rational number can be represented on a number line. 0 is neither a positive nor a negative rational number. A rational number a by b is said to be in the standard form if its denominator b is a positive integer and HCF a comma b is equal to 1. There are unlimited numbers of rational numbers between two rational numbers. Today, in this part, we are going to see the comparison of rational numbers and basic arithmetic operations on rational numbers. Learning outcomes. To understand the comparison of rational numbers. To learn and perform the 4 basic arithmetic operations and solve word problems on rational numbers. Keywords from this lesson: positive and negative numbers, fractions, numerator and denominator. Addition, subtraction, multiplication, division and inverse. Comparison of rational numbers. It is useful to remember the following points. Every positive number is greater than 0. Every negative number is smaller than 0. Every positive number is greater than every negative number. Every number on the right of a number on a number line is greater than that number. When two integers or fractions are given, we know how to compare them and say which is greater or smaller. Now, in the same way, we can compare a pair of rational numbers. Type 1. Comparing two rational numbers with opposite signs. Example. Compare 5 by 17 and minus 10 by 19. Solution. Since every positive number is greater than every negative number, we conclude that 5 by 17 is greater than minus 10 by 19. Type 2. Comparing two rational numbers represented by two fractions with the same denominators. Example. Compare 1 by 3 and 4 by 3. Solution. Since the denominators are the same, just compare the numerators. Since 1 is less than 4, we conclude that 1 by 3 is less than 4 by 3. Type 3. Comparing two rational numbers represented by two fractions with different denominators. Example. Compare 3 by 4 and 5 by 6. Solution. The LCM of the denominators is 12. Find it. Consider for each rational number an equivalent rational number with the LCM 12 as a denominator. We get 3 by 4 is equal to 9 by 12, and 5 by 6 is equal to 10 by 12. Which become like fractions now. Here 9 by 12 is less than 10 by 12. Hence, we conclude that 3 by 4 is less than 5 by 6. Type 4. Comparing two rational numbers that are not in standard form. Example. Compare 9 by minus 4 and minus 2 by 3. Solution. The number 9 by minus 4 is not in standard form. So first, put it in the standard form. Nine by minus 4 is equal to 9 by minus 4 into, we multiply numerator and denominator to minus 1 to get a positive denominator. So that is minus 9 by 4. Now we shall compare the fractions minus 9 by 4 and minus 2 by 3. We find that these two fractions are unlike fractions. To make them like fractions, we make use of their LCM, which is 12. We can now compare the equivalent fractions. 9 by 4 is equal to minus 27 by 12 and minus 2 by 3 is equal to minus 8 by 12. How? We find that the denominators are the same, and so just comparing the numerators minus 27 and minus 8 is enough. Visualizing these numbers are on the number line. We see that minus 8 is placed to the right of minus 27, and hence minus 8 is less than minus 27. This leads to the result that minus 8 by 12 is less than minus 27 by 12, and consequently we conclude that minus 2 by 3 is less than 9 by minus 4. Basic arithmetic operations on rational numbers. All the rules and principles that govern fractions in basic operations apply to rational numbers also. Addition. There can be 4 different situations while doing addition. Type 1. Adding numbers that have the same denominators. This is simply like adding fractions, and the result is the sum of the numerators divided by their common denominator. Example. Add minus 6 by 11, 8 by 11 and minus 12 by 11. Solution. Write the given rational numbers in the standard form and then add them. Minus 6 by 11 plus 8 by 11 plus minus 12 by 11. We can see 11 is the common term. So we take that as the denominator, and minus 6 plus 8 minus 12 is the numerator where we add all of them. After addition, the final answer we get is minus 10 by 11. Type 2. Adding numbers that have different denominators. After writing the given rational numbers in the standard form, use the LCM of their denominators to convert the numbers into equivalent rational numbers with a common denominator so that this reduces to type 1. Example. Add minus 5 by 9, minus 4 by 3 and 7 by 12. Solution. Let's take the LCM of 9, 3 and 12 first. So after taking the LCM, we get 36. And then let's see if 9 is divisible by 36 or not. So it goes 4 times and we same multiply it to the numerator. Same goes for the rest. 3 and 12. 3 goes 12 times and 12 goes 3 times. So minus 5 into 4 is minus 20 by 9 into 4 is 36, and then minus 4 into 12 which is minus 48 by 3 into 12 which is 36, plus 7 into 3 which is 21 by 12 into 3 36. So now we see 36 is to be taken in the denominator, and minus 20 minus 48 and plus 21, and the final answer we get is minus 47 by 36. Additive inverse. The additive inverse of a rational number is another rational number that gives 0 when added to the given number. For example, 4 by 3 and minus 4 by 3 are additive inverses of each other since their sum is 0. Is 0 a rational number? If so, what is its additive inverse? Yes, 0 is a rational number. The additive inverse of 0 is 0. Subtraction. Subtraction is simply adding the additive inverse. Example. Subtract 9 by 17 from minus 12 by 17. Solution. Minus 12 by 17 minus 9 by 17 is equal to minus 12 by 17 plus of minus 9 by 17. So we know the denominator is the same. We subtract minus 12 by minus 9 by 17, which gives us minus 21 by 17. Multiplication. The product of two or more rational numbers is found by multiplying the corresponding numerators and denominators of the numbers and then writing them in the standard form. Example. Evaluate minus 5 by 8 into 7 by 3. Second, minus 6 by minus 11 into minus 4. Solution. The first one, minus 5 by 8 into 7 by 3 is equal to minus 5 into 7 by 8 into 3. 5 times 7 is minus 35 and 8 times 3 is 24, which is the answer. Second one, minus 6 by minus 11 into minus 4, which is given. Where we write down first minus 6 by minus 11 into minus 4, we do not have the denominator over here, so we put 1 in the place of denominator. And the final answer is minus 24 by 11. Multiplicative inverse. If the product of two rational numbers is 1, then each of them is said to be the reciprocal or the multiplicative inverse of the other. What is the multiplicative inverse of 1 and minus 1? Solution. Multiplicative inverse of 1 is 1 and minus 1 is minus 1. For the rational number a, its reciprocal is 1 by a and vice versa, since a into 1 by a is equal to 1 by a into a, which is equal to 1. The rational number a by b's multiplicative inverse is b by a, and vice versa, since a by b into b by a is equal to b by a into a by b. Everything gets cancelled out and we get the remaining answer as 1. Division. The idea of reciprocals of fractions is also extended to the division of rational numbers. To divide a given rational number by another rational number, we have to multiply the given rational number by the reciprocal of the second rational number. That is, the division is simply multiplying by the multiplicative inverse of the divisor. Example: divide 7 by minus 8 by minus 3 by 4. Solution. Here, 7 by minus 8 divided by minus 3 by 4 is equal to 7 by minus 8 inverse of minus 3 by 4 is to be seen. So that becomes into minus 4 by 3. Cancelling, 4 times 2 gives us 8 and the final answer is 7 by 6. Example: the sum of two rational numbers is 4 by 5. If one number is 2 by 15, then find the other. Solution. Let the other number here be x. Given 2 by 15 plus x is equal to 4 by 5. X is equal to transporting 2 by 15 to the right hand side. We can see 15 is the LCM over here. We see that 5 times 3 is 15 and the numerator also gets into 3 multiplied. 4 times 3 is 12 minus 2 by 15 is equal to 10 by 15. Now the value of x is equal to 2 by 3. 5 times 2 gives us 10 and 5 times 3 gives us 15. And that's how we get the value of x is equal to 2 by 3. Example: the product of two rational numbers is minus 2 by 3. If one number is 3 by 7, then find the other. Solution. Let the other number be x. Given 3 by 7 into x is equal to minus 2 by 3. Now multiplying by reciprocal of 3 by 7, that is 7 by 3 on both the sides. So that becomes 7 by 3 into 3 by 7 into x, where 7 and 7 cancels out and 3 and 3 cancels out and we are left out with only x. And then we are equating it to 7 by 3 into minus 2 by 3, where the value of x is minus 14 by 9. Points to remember. Subtracting two rational numbers is the same as adding the additive inverse of the second number to the first rational number. Multiplying two rational numbers is the same as multiplying the numerators and denominators separately and then writing the product in the standard form. Dividing a rational number by another rational number is the same as multiplying the first rational number by the reciprocal of the second rational number. Thank you for watching.